This is page 12 of the fault tolerance notes, and we're going to start by working through a simpler example with 4 generals. One is treacherous, and I'm going to number the generals. The commander will be General 1, and the lieutenants will be 2, 3, and 4, and you want to space these out a bit to give room for the messages that will go between them. So in the initial setup, the commander sends a command to each of its lieutenant generals. Attack, attack, attack. And now the recursive algorithm kicks in, and I'll show that in green. So it will start with M is 1, and Lieutenant 2 will act as commander, sending the value it received, attack, to each of the other 2 lieutenants. So it will send attack to 3, it will send attack to 4, and likewise Lieutenant 3 will take its value and send the value attack to 2 and to 4, and Lieutenant 4, for the sake of argument, or for Lieutenant 4 for this example, is the traitor, and so it's going to send retreat and retreat to 2 and 3. And the final level of recursion invokes algorithm OM0, where each lieutenant uses the value that it received from its commander. So attack, attack, and 4 is an unreliable component, so I'll just say that it uses X. Now we start to back out of the recursion. So we recursed in, now we're recursing out. So in step 1 up above, Lieutenant 2 sent out 2 values. It also received 2 values. There's 2 arrows going to it from 3 and 4 with an A and an R. And so what it needs to do is in step 3 it needs to take the majority value that it's received. So I will call this value V2, and that's going to be equal to the majority of it heard attack from itself, or sorry, from its commander, and it heard attack from Lieutenant 3, heard retreat from Lieutenant 4, and so it will take the majority of that and it will decide to attack, and Lieutenant 3 will take the majority of the values that it received. So it received attack from Lieutenant 2, it heard attack from the commander, and it heard retreat from Lieutenant 4, and again the majority value is attack. And Lieutenant 4, what decision it arrives at, we don't care. In this example, it's a faulty component, it's going to do something invalid or unreliable. And so the goal of this algorithm was that one faulty component could not cause the remaining reliable lieutenants to come to either an inconsistent or an invalid decision. And so we can see that the commander was loyal and it sent out attack to all 3, and Lieutenant 2 arrived at a decision of attack, so did Lieutenant 3, and so the algorithm has succeeded.